So thank you, Charles. So today's webinar is entitled Ask an Engineer. Uh, I'll be moderating the presentation. I'm Marc Rousseau. I head up the national accounts team here at Damotech. And my partner in crime, who will be fielding all the tough questions that you all will be asking, is Charles Carbonneau. He's our chief engineer. There we go. So he's a PhD in structural engineering. He's been living and breathing all sorts of structures for some time now. Focused on the Damotech specific stuff and racking for, I would say, almost the last 15 years. But we would encourage you to ask the questions that you have. We're hoping to make this a lively event. So with that, we'll continue. So who we are, for those that aren't familiar with us. We're Damotech. We're the North America's largest rack safety partner. We were established in the late 80s, primarily focused on rack repair and protection, but about 15 years ago, we pivoted towards including engineering services focused solely on pallet racking as part of our portfolio. So we specialize in that sort of engineering. With over 35 engineers on staff, we service a variety of customers throughout North America. I would say nearing 300 Fortune 500 customers call on us to be their trusted partner. And among the products and services that we offer, I've already talked about a few, but fundamentally on the engineering services side, we'll do third-party audits, also called compliance inspections, load capacity calculations. We do rack safety training for those that want to be able to perform their own self-inspections. And of course, we offer a suite of rack repair solutions to include protection of racking as well. All right, so as I'd mentioned already at the beginning of the call, today is Ask an Engineer webinar, so you'll have an opportunity to ask all sorts of questions relating to pallet racks and questions that you might have about things that are of concern to you. There's a button towards the bottom of your screen that has the Q&A button there. So if you navigate to that to ask your questions, we'll be able to run through those one by one and hopefully tackle some of the concerns that you have where you are working today. So Charles, we have a question from Stuart. What are the acceptable limits for damage to a beam? Damotech has guidelines for go, no-go damages to other components, but not beams.
Okay. Well, first of all, hi, everyone. Thank you for joining us in this webinar session. I'm not going to be alone, Marc. We have a couple of more engineers that I asked to join because I don't know everything. But for sure, if they can help. So I've got Jason Beaulieu and Josh Takenaka, who's in Toronto, listening in. So guys, if I answer wrong, don't mind. Mind telling me. So to get to the question about acceptable damages to beams. So there's all kinds of possible damages. Anything that has to do with the connectors, it's a replace immediately. We don't mess around with this. If the weld seems to be broken, just replace it. For the cost of a beam, you don't risk anything about it. We've seen all kinds of damages, especially the ones at the bottom for people using double deep systems. People tend to push the bottom beam and it gets badly damaged. Now, in terms of damage, too much is too much. At one point, even a 5-year-old will say, that doesn't look good. And you have to put yourself in the shoes of the original rack manufacturer. If something happens, like a collapse or something bad, somebody gets hurt, they come in and they say, that's not my rack anymore, right? That's not what I gave you. And it's on you. In terms of deformation, a small dent in the front, with the forks, usually is not that big of a deal. If the beam is not straight anymore, it's kind of, kinked inwards or even outwards when you're trying to pull off something, that would be a replace immediately. But in terms of how much, how much of a dent is too much. Usually the codes will not say how and how much. They don't want to get involved in that because every situation depends on different criteria. How long is that beam? Is it going to buckle under load? How much load there is on it and whatnot. So they don't provide clear guidelines. Usually they say, well, have somebody that really knows this stuff come in and look at it. And even for engineers, it's really hard because an engineer would have to kind of take the beam out of there, put it under load, and confirm that it was about to give. And so usually we don't mess around too much with damaged beams. But like I said, a little dent from the forks in the front. I read somewhere that if it's not deformed all the way up to the top and bottom flange, if it's not bent with that frontal hit, you're good. You're still good to go. But again, depending on the type of beam, it might be more prone to having a local buckling. It's a really tough question to get me started. Come on, Marc.
That was a great answer. It's a tough call, I think, as we're trying to conclude from this. And oftentimes it's good to pivot and ask for professionals to come out and actually assess the context that you're
Yeah.
dealing with, because not every situation is going to be necessarily the same.
Yeah.
But thank you
If
for
I
that.
can add to it, sorry, and I'm just thinking right now, I've seen beams damage, from the bottom. So somebody, I guess the forks, just hit the bottom of the beam. The beam just did not dislodge, but it is deformed at the bottom, like very locally, right? And so when you have these vertical loads pushing down on it, there's not a whole lot of effect on the capacity of the beam itself. But if you have that much deformation on the bottom of the beam, what happened to the connectors, right? Things that are hidden from view, right? Because the connector is inside the column, you don't really see what happened there. So it's a matter of dislodging the beam, to have a close look at it. And while you did that, just replace it and be done with it.
That's a fair point. And an add or a part B to that. What if the beam is deflected significantly, right? What if I'm looking at it and it's got this curvature to it, not necessarily from impact? What are some of the precautions that I should take if I see something like that?
Yeah, thank you for bringing me there, because the code says in terms of deflection, natural deflection under load, we're limited to the length of the beam divided by 180. Okay, that's the tolerance on deformation. But the capacity of the beam, the way we calculate the beam is it's supposed to resist, and the column connectors and the column itself, the holes in the column or the bolts if it's bolted, they're supposed to be able to resist at least twice the design load, right? So if it bends a lot, the beam, it doesn't mean it's going to break, right? You might be beyond tolerance in terms of natural deflection. Now, if you remove the loads on a deflected beam like this, you remove the load and it's still showing like it's bending like, I don't know, 1/4 inch, that's not normal, right? It should be replaced at that time. So again, for an 8-footer, it's about 1/2 inch of deformation, and that's a lot. When you're in front of it and it's loaded, you will see that it's bending, or when you walk down the aisle, all of the beams are going like this. It is normal if it's at 0.5, but if you remove the loads and it's 0.25, that's not normal. It should be pretty straight.
Super, super. Thank you for that, Charles. A question here from someone else that just joined. It has to do with the codes that are applicable to various states. So is there a code that applies to everyone? And how does California fit into the landscape of codes and requirements for racking?
Yeah, that's an excellent question as well. So I know that the IBC, the International Building Code, refers to MH16.1 for a pallet rack design. And so we all have a building code. Canada has a national building code. The US has the international building code. In that code, it's about all buildings, but in there's an article that talks about racks, and racks are to be designed with MH16.1 in the US, and in Canada, it's the S345. So two design codes. They don't say exactly the same thing, but of course, one influences the other, and it's math, right? So at the end of the day, it should work. In California, there's the California Building Code. They have another code that will guide you into each different aspects of each municipality. It's to that point. Different rules left and right. So some will have will ask something really, really specific about the anchors. When you install a brand new rack, somebody's got to come in and inspect the anchors, and that's got to be done. Some other cities with lower seismicity level will not ask for those. So I don't have the name of that code in head right now, but I'm pretty sure I have it somewhere. So that might be a part of the information that we can send maybe after the webinar.
Absolutely. Okay, great. Thank you, Charles. Another one here. Do anchors need to be placed in all available anchor points? So if we think of a foot plate, in some cases, they'll just have 2 holes in them. Sometimes they'll have 4. So is an installer or somebody installing rack having to put anchors in all those? Can you help us answer that?
Yes. So the answer is not yes, and it's not no. It depends. And it depends on the LARCs. So LARCs are the initial stamp drawings by the engineer that designed the system. So I repeat myself very often every time I have an opportunity to do so. It's not because you have a big fat seismic footplate with 4 holes that you have to fill them all. Right? It's supposed to be written somewhere in the documentation that comes with that rack how to do it. I've seen locations where they ask for it to be in diagonal, knowing that maybe you hit a rebar under one hole and you try to use the other hole and whatnot. So there's a certain logic to it, but that is specified by the design engineer. Same for the lower seismic zones where you only have these 2 holes in the back right there. Oftentimes, because we don't expect that footplate to prevent any rotation at the base. The rotation is kind of, when we do the analysis, we think it's like free rotation at the base of the column. It's not resisting any down aisle forces. The anchor is there to prevent, if you slightly hit the column, that it twists too much, that it moves too much, I'm sorry. And it's there especially for uplift forces that you could have on the rack system. So the design engineer is specifying, I want 1, I want 2, and you can also revert to call back the design engineer and say, if I put a second one, because I want to prevent my columns from twisting, if I slightly rub against them with the pallets, then they might tell you, no, don't do that because the proximity of the anchors is too close, or they will just say, yeah, go ahead. It makes everything better.
Okay, great. Thank you. Question from John, and we see this quite a bit, so I think this will answer a few other questions that are in the queue, but what do you suggest for legacy racking? In other words, there's no manual, there are no LARCs, there's just nothing existing in terms of documentation for racking that's already been installed. So if they're looking to rebuild, their documentation and have everything looked at, what are the steps to determining, to getting LARCs and looking at load capacity for stuff that's already been installed?
Yeah, so many warehouse environments are in that situation where they completely lost track of these LARCs, the stamp drawings or some kind of report stating what's the capacity of the racks. They might still have on the racks displayed, capacity per pair of beams or per pallet or whatnot, but no clue as to were there any modifications made to the racking system. And by the way, again, if you move beams around in height, beam levels per se, you are modifying the load capacity of the entire rack system, especially at that location for sure. But if you do it for the whole system, you might be overloading the rack system. It's quite dangerous to do so. So that's one of the services that we provide at Damotech. We kind of realize that if you have a large warehouse and you have multiple rack providers and their original rack manufacturers of different kinds through the years, at one point, nobody knows where this is from. And even identifying the type of rack is hard because I believe in 2012, was it mandatory for rack manufacturers to stamp their racks so that we can identify what it is. And so if you have racks before that, maybe they're not identified, maybe their rack manufacturer doesn't even exist anymore. So what we do at Damotech, we send in a team of engineers to go and measure everything and reverse engineer the whole system to provide you with loads. Now, once we've done that, we put all of that information in our web platform. That is kind of a way to manage finally all of that type of information where, the analysis report and all the capacities is stored there. Can't lose it. It's on the web.
Right.
And every change, every modification that you do in time can be kept at that location. So that's how we address that kind of situation. Now, you had previously to that portion, you were saying, if I have old racks, but I do have my documentation, do I need to recalculate everything? Do I need to have that service done? And the answer is, well, if you did not do any modifications to the rack, you do maintain them. Maybe you swap uprights that were damaged, right? But you change same for same. And maybe you do some repairs that just bring back the old capacity of that rack, and you're not modifying beam elevations, you're pretty good. Even though the codes evolve and change, to take into account better seismicity factors left and right, as knowledge grows and whatnot. Usually, if you apply a more recent design code, like the latest American one is 2023, and so is the Canadian one, I believe. Very, very close. And they are more stringent on seismic analysis. And so a lot of people will, if you do that, you will expect a loss of capacity somewhere. But codes are not forcing us to go there. Like I said, if you didn't modify your rack and it was calculated 20 years ago, well, it's still holding, it's still there, yep. It's good. If you modify the rack, right, you start changing beam elevations, you need somebody to tell you if it's okay. They're going to do it to the latest code.
I see. Okay. So I'm going to throw a curveball your way. So yeah, I know you're squinting. What about challenges around a roof supported structure? Do they have to treat those any differently?
Well, we do on our end, because we're talking the building structure now,
That's right.
So racks that are supporting the roof, if it, again, those usually you don't modify that much, right? It's a big tower. It's something rather big. You don't play around with beam elevations. If you do, go back to the original rack manufacturer, who, right, for sure, because it's a building, come on, they're not going to lose that documentation. And I expect that even the fire station nearby has those plans. They have the documentation. They probably have even the capacity, but although I'm not 100% sure. But because it's part of the building, it's not something you can remove easily. It's really well documented. So you can go to the city office and get your plans, I'm pretty sure.
So touching on the documentation piece, OSHA came out with their national emphasis program, I think it was last year, where they're focusing more and more on warehousing and distribution because they're seeing a degree of accidents that is considerably higher than maybe other industries. So in terms of documentation, what are the sort of things that an OSHA inspector might be keen on seeing if they were to come visit a facility for a variety of reasons, right? Because the whole thing about the National Emphasis Program is if somebody comes in because somebody called OSHA and said, hey, the fire exit is now
Yeah.
blocked. I'm concerned about, a means of egress in case of a fire. If the OSHA inspector comes in and looks at that fire egress and says he has every or she has every right today because of the NEP to now pivot away from that and say, hey, let's go take a look at your racking. So if I want to stay in good graces with OSHA, what are some of the things you think I should have on hand to make sure I'm in the clear?
Right. So 2 points. Of course, an inspector, if he sees damage, like I said, a 5-year-old can tell damage from something else. So 2 points. If you have up-to-date LARCs, the the stamped engineering drawings or some form of report calculation that states the capacity of your racks, and that person can ask for that anytime. They have that power to say, okay, show me your LARCs, right? What do you have? And you might say, well, we don't have precise engineering drawing, but we have a company that came in and did this mandate. Here's our capacity. Okay, you're legit. That's good. The other point that they want to know is, well, I saw damage. What do you do to handle that damage? And then, if you do things right, you maintain that inspection and repair or replacement documentation close by. It's a big folder with every intervention, trainings that you've done in that direction. And it's kind of the same that if the insurance company, if they were to come by, I don't think they visit that often, but if they were to come by, they just want to make sure, how do you keep on top of these things? And so these 2 points, have your capacities somewhere clean, and also a folder with what you're doing to maintain the racks. And that's a responsibility on the shoulders of the warehouse owner or warehouse manager, right?
Because that's the things I think what I've also often heard with OSHA inspectors, um, the presence of a load capacity placard or labels, and that's kind of black and white. You either have them posted or you don't. And often folks will get dinged on those kind of things because they just acquired a warehouse and it's been a couple years and they haven't really looked at the capacities or more worried about the operational effectiveness of their facility. And that's just one thing that I've heard that the OSHA inspectors are very keen on because there's no debating whether you have you either have the load capacities or you don't have them posted,
Yeah.
right? So
Yeah.
that's
Yes, and you raised a good point with the markings on the rack. So that's part of the code. The code says you have to display the capacity so that at least forklift operators have a chance to not overload the rack. That's the spirit of it. Uh, uh, Depending on how knowledgeable the inspector, the OSHA inspector is, he will or she will really understand that, whatever you have printed on the racks, that's not holding the load, right? Because you can
right.
swap beams and then it's not
That's
saying
right.
the right thing. You could have modified the rack and now the plaque at the end of the aisle doesn't say the right thing anymore, but nobody knows. So they might just say, hey, show me that report, that calculation, where we hold all of these different beam configurations and upright configurations and we state the capacity. So that to me is the main document.
Okay, that's awesome. And now, if I drill down a bit more on the OSHA piece, now I know there are third parties like Damotech that can come in and perform an audit, and that's a good record to have as part of your OSHA folder or your rack safety folder. Should companies, warehouse owners look at performing their own inspections, or should you just rely on a third party to come in every once in a blue moon?
Yeah, good point. So we have quite a lot of experience with this also. So those who try on their own, right? There's a initial cost of trying to train your people, and the biggest hurdle that they have to go through is if you take somebody from the floor and you tell them, "I'm going to train you to recognize damage." Yeah, that's rather easy, but to rate it in terms of how bad it is, how urgent it is, now they feel a lot of weight on their shoulders. And that's usually what stops employees from joining that type of program to self-inspect. I'm not saying it's impossible. Of course, it is. So what we recommend usually is to have at least baseline inspection from professionals that state clearly, okay, well, we saw that dent on the bottom of the column here. It's dented by about a quarter of an inch. That situation does not worry us. That's on the low end. We saw it. It is a damage. I saw it,
Right.
right? But don't worry, you've got bigger problems. And so the professionals will kind of rate all of these issues. Sometimes it might just be, you have an unclipped beam, partially unclipped beam. That is not even a red. That's unload right now. It doesn't leave the facility without you unloading that beam or just fixing the problem. So these are the kind of situations where you say, oh, that's really urgent. Somebody can get hurt badly. On
So,
other
so
types of damages, like column damages, sometimes
yeah.
because you have an idea of how much load there is in here, we're in a big seismic zone. You might say, okay, yeah, unload partially the rack. And that's really hard for an employee to say, because they understand also the consequence on the business and they don't necessarily have the authority. So if I report too much, I'm hurting my own company. If I don't, well, it's my responsibility. So it's hard on them, I would say.
so if I stay on that topic a bit now, we had a question that just came in, and tangential to the idea of training. How do you get leadership from a facility or a company, the people who own the purse strings, to kind of get on board with this idea of inspections and load capacity assessments and risk? So how do you get them to understand the importance of making sure these things get done?
Right back at you. I think you're
So
better
so
than
thank
me
you.
on that
Thank you.
question.
No, no, that's okay. I didn't want to just come in myself and answer the question, but the question came in, and I think it's very pertinent. If the attendees navigate to our website, there's um, this concept of
Oh,
a flywheel that we have.
yeah.
And the flywheel, I think, tries to express in a visual form. Yeah, I think you're going to go there right now.
Yeah.
What rack safety means, and how you could convince your
Yeah,
your
that's the one to
leadership
get
about
it.
the importance of it. Yeah. So I think fundamentally it's just a way of describing the importance of rack safety. So it means, why is it important to have a rack safety program? I mean, are we concerned about our people? Are we concerned that they're going to be working in an environment that's potentially unsafe? Are there, here we go. Are there corporate guidelines or forcing functions that require me to be compliant? Some companies, don't necessarily have a corporate rack safety program. So that's where OSHA and folks like those organizations come in, because they become the forcing function to ensure that you understand why rack safety is important. And then I would say the third leg of the stool is the operational efficiency element. I mean, you can't tell me of one VP of operations who's sitting there 2 weeks before the start of peak
Mhm.
and who's not concerned about the pallet space that they have in their racks. If 10% of your racking is put out of service because of damage, that should get someone's attention. So getting ahead of the curve, making sure you have a good program in place is not only good for the safety of your employees and ensure that you're compliant, but also makes that you're now able to store the products and goods that you're going to need to send out of your warehouse, when it comes time. So the flywheel that you see on the screen there speaks about the inspection process. It speaks about getting insight from your inspection to make sure that whatever conclusions are drawn, that those things are well understood. There's an aspect of maintenance. So once you have all these wonderful conclusions and this insight from the inspection, what's the plan of action to address all these important these point items? And then, of course, lastly in that is, how do I get ahead of this to prevent it from happening in the first place? So as you're looking to encourage the leadership to get on board with rack safety, I think using the flywheel and the various bits of information that we have on our website and on our blogs, I think will go a long way in getting them to understand why it's important.
Yeah.
I'm going to come back real quick, Charles, because I didn't want to miss this, but coming back to capacity, because it's a very, very active topic. I mean, a lot of the questions that I'm seeing have to do with capacities. And you mentioned how, moving beams up and down can have an effect. Can you give us like an order of magnitude sense of what happens when I move my beam? Am I losing a little bit? Am I losing a lot? How do the engineers kind of view these things?
Yeah, I'm not going to show the little video, but we have a small video about this. I think it can be found on the web. Do you know, Mark?
Yeah,
The rack
I
collapse
think,
video.
yeah, I
But
think, yeah, I think so. I think so.
but anyway, usually I show it with using a small plastic ruler. So I've got one right here. Not sure
Yeah.
it's very visible, but here's a plastic ruler. So basically, when you have compression coming down from the loads, right, we understand that these two extremity uprights will receive half of the load of that middle one, because that middle one is receiving pallets from the left and from the right. So everything is condensed down here at the bottom. And that first beam elevation is usually, typically, not all the time, but most of the time, that's the one controlling the capacity of the rack system, if we're just talking gravity loads, you know. And so the phenomena here is we're trying to design this thing not to buckle. And buckling is a very violent reaction where the column just goes, but really fast. You don't see it coming, it just collapses, it crushes. And so here's an example. If this is my first beam elevation, this is the ground level, and I push on this little thing, it looks straight, it looks perfect, but in reality, it wants to flex. Everybody understands this, right? And if I hold it in the middle, so let's say that the example now is if I have this middle beam, it is kind of laterally supporting this. If I try to collapse it, it's going to take 4 times more force actually to be able to collapse it. So if you do it in reverse, you had a beam elevation here, you remove it completely, and now it's from the ground all the way up to here. Well, I lost 4 times the capacity. I can't even fill the whole thing, right?
4
Like it
times the
used to be.
capacity. Wow.
Yes. So it's a bit like I have 4 beam levels that were filled. Now that I removed one, I cannot have 3. It's got to be only 2, right? And again, your limit. So that's a general rule. It's a little bit more complex when you enter with the seismic behavior of the racking system, because it's going to sway quite differently now that we only have 3 beam levels to laterally support it.
Yeah. Okay. That's great. Thank you. So we have one here that came in, talks about having a rack next to or in proximity to a wall. Do we have to tie the rack to the wall?
Oh, no, no. So again, I can go back to the LARCs, the original LARCs. If the rack design engineer said, I need to tie this rack to the wall, he had to have a conversation with the building engineer. They had to talk to each other because he might be imposing some loads onto the wall that were not planned by the building engineer. So they have to work together. If you take that decision yourself, you say, well, it feels wobbly, that rack. I don't like how it operates. We're going to tie it to the wall. Well, you're taking a decision that might be impactful on the building itself. And if there's a collapse, you're pulling on the building, perhaps. So you're looking at an even worse situation now. I've rarely seen this. So when we design a rack, we design it to be autonomous. It's because we don't know exactly how they're going to set it up in the warehouse. The reality of construction versus your planning and whatnot, it might change. The expansion joint in the concrete have moved slightly, and so you have to adapt because you cannot set up your column directly on top of it. So you adapt, you adjust, and attaching to a building usually is not a good idea.
So on that, anyway, these questions are just coming in like like crazy. But on that topic, is there a certain distance that we should be looking at from whether it's a building or a wall or it's another structure? I mean, what should folks kind of be mindful of?
Yeah. So the design code says, as a general rule, you should be away from any building component or even other rack systems. It should be like 2% of the height of the top beam, right? 2% of that distance in the cross aisle direction. So that's in the plane of the uprights. So if there's a wall like here, so I have this structure, which could be ventilation or whatnot in the back. I need to be 2% off of the height of that last beam, right? That's a general rule. So if you're in a higher seismic zone, it might be higher, but it's calculated by the design engineer and they usually position the rack to a certain distance, and that's going to be in the LARCs in the original drawings. Now, in the down aisle direction,
Yep.
they sway much more. And so the tolerance is 5% off. And that
5%.
applies, if I have a rack going in that other direction, it would be perpendicular like this. I
Right.
should be off by 5% at least in this direction. But if it's two racks, you have one rack here, another one, and they're in that continuous line, they might bang into each other. So you might want to spread them out a little bit more. When we get to these situations, usually we do a full seismic analysis, and then we discover the true expected down aisle deformation during the earthquake. And so we can space them adequately. Same thing, when you have a column going through the rack system in a high seismic zone, the upright must be away from that column sufficiently so that it doesn't bang into the column. And the same, in the cross aisle direction, the beams must be far away from that column. Otherwise,
Right.
if they bang into it, you might dislodge the beam and then products fall.
Okay. Okay, that's great. Thank you. Another one just came in. I'm trying to mix them up a little bit, but this has to do with the orientation of an upright. Some say they should alternate the orientation of an upright, in terms of the bracing front, the bracing at the back. And is there a way of looking at these things that we should be mindful of as we have new racks installed or swap them out or stuff?
Yeah, interesting. So the way we design the rack systems for us, if it's just a single row like this, it doesn't really
Yeah.
matter that much. It's got to
Okay.
work.
Right.
So it's got to be able to support both vibrations cross aisle. So we're talking about here the orientation of these braces, right? Does it need to be front facing at the bottom, going up in the back? This is how we at Damotech explain it usually is that, well, if you're going to get a front impact, it would be better to have that brace right here connecting to the front. So when
Right.
you hit it like this, it doesn't bend right away. If you hit it like this, you understand there's not much to prevent it from just bending. And then once it's kind of bent, I'm coming back to my little ruler here. Once the bottom of the column is kind of bent, if it wants to buckle, you're telling it where. You're telling, okay, well, just
Right.
add some more load and it's just going to go from that point on. So alternating, one direction and the other is not bad. Usually
Right.
that's not what the manufacturers say. And so second answer to the question is,
Yeah.
well, usually the rack manufacturer oriented the uprights in a certain way. Just repeat that. Don't mess around twisting them. The third answer to that question is if they are back-to-back systems, it's really important to mirror how they are made. So not necessarily all manufacturers. So when you ask for a rack system, the manufacturer is going to try to optimize the structure as much as possible so that he wins the contract, right? So he's
Right.
trying to minimize cost. And so these structures are very efficient, very optimized because of price of steel, right? And fabrication and whatnot. But if you're back-to-back system, the design engineer might be counting on the fact that, okay, this brace here, when the rack is moving in that direction, seismic wise, right?
Yeah.
It's putting compression on that brace. And that compression, that's the weak spot of a thin brace. You put it in compression, it's not super strong. You put it in
Yeah.
tension, it can take a lot, and
Right.
usually the limit is the welds at the
Sure.
extremities. And
Right.
welds are a stronger steel even than the original brace itself. So if you make it back to back and it's mirror-like, on the other side, I'm going to have a brace that will be in tension, right? And since both racks are attached together with row spacers, then the two sides are working together under seismic forces. And that's important to respect that. If you put them all in the same direction, back to back, well, you won't have that effect.
So I know we're 45 minutes in, so a bunch more questions have come in. I don't think we're going to be able to tackle them all, but I'm going to ask this because we've talked about seismic forces a few times already, and there have been events in California recently. I would say even in other parts of the country recently where there has been a seismic event. If I have a warehouse and racking that just underwent some form of seismic event, what are the things that I should be looking for, or what the steps I should take to make sure that my racking is still, okay to operate?
Okay. So I know that for buildings in California or anywhere where you had an earthquake, usually you need an inspector to come in, depending on the size of the earthquake, of course. Like the Northridge earthquake in California way back, steel structures were affected more than other types of structures. And so you need to have experts that really come in, inspect, and then they open the walls, to look at your steel connections and how they behave to make sure that you can reintegrate the building or that you need to retrofit somehow. So it's kind of the same for racking systems. First of all, if it would stand the whole seismic event, congratulations, that was a well-designed systems, and there's plenty of those, right? Especially in California. Um, uh, so the same kind of inspection should be done by a professional because now we're looking at slight deformations, slight indicators. They're not necessarily damages. We're really looking for slight little things that have changed. Um, if the racks are out of plumb, for example, and they stay out of plumb, that's really suspicious. It's not supposed to do that. If you see through the paint little black lines around the welds, that might be broken welds, right? It did sustain the whole seismic event, but now could it take another one? That's the kind of questions that we get into. The indicators are not that specific, right? So it depends on the type of system, depends on the seismic level that
Right.
you attained.
Okay, now this is I think we might have a hard time answering, but Greg just asked a question around permitting. If it's a responsibility of the business owner or the distributor or seller to ensure that permitting is completed. I don't know if you have an answer to that. I know it's not something that Damotech will typically get into.
Mhm.
We aren't involved in the documentation needed for the permitting of a new rack. That's oftentimes Are there groups that do that? But do you have something you could share on that particular point in terms of responsibilities for permitting?
Unfortunately, no, I'm not knowledgeable on these points, but I know that it depends. So, because I've got experience in the building on the
Sure.
building side of things, and it's varied. It depends, because you might say, oh, I take care of everything, do it.
Yeah.
So it's a
Yeah.
different partner,
Yeah,
that's going to
you'd
do
you'd
that.
think that ultimately whoever owns the racking will have that as part of their contract with the seller of their racking to ensure that everything is done. Because ultimately that permit will reside with the owner of the rack, not the
All
distributor.
right, correct.
But I would
But
think
it could be part of a package, right? Just
exactly correct. I know certain jurisdictions, shoot, I mean, in California, the number of counties they all have slightly different tweaks to
yep.
the various county regulations. But Greg, certainly happy to take that offline and put you in touch with somebody that maybe has a deeper understanding of the permitting requirements. But otherwise, again, we're maybe another minutes that we have, and I'll take this last question before we kind of wrap things up. It has to do with racking that's been around, say, for 30 years. Let's say you acquire a business, and yes, this idea of capacity, but should somebody be worried about racking that's been around for 30 years? I mean, is there a fatigue that takes place? Is there like, this thing has been pushed, it's been loaded umpteen times. Is there a consideration for that?
Yeah, and by the way, that happens often where somebody will have us do an initial baseline inspection on something
Mhm.
that they think they're going to buy. They just want to know how much
Right.
more investment they need to do and to bring it up to date. And yeah, definitely, if you're not too familiar with the rack's history, who operated it and how, there's something to be known there. Rust is also something that could be a problem. Sometimes, they stored the racks outdoors for a while because they were renovating indoors. And so you had rust that appeared, and how much rust is too much rust, that's really hard to determine. So a professional comes in and then they can provide you with real answers to that. But yeah, a 30-year-old rack, start to worry. A little point about this, so when we go in and we know we're dealing with something that's rather old, we can always tell, how much beating the rack has endured. If it's not repaired, that's the main focus. You have to do something. Don't leave it like that. You have to act on that rack system. But then again, something that is almost total, the engineers will just say, no, I'm not going to put my name on this thing. I'm not even going to try. I'm going to tell you, no, you need to change this. It's done for, right? And that's also a way of helping out, because if you're trying to put money on something that's worthless, in the end, you're just wait. It's a waste. So
Of
yeah,
course.
it's part of our approach.
Okay. Well, I
And
think
Mark, I didn't want to leave you guys off without talking about our blogs. There's tons
yes.
of answers in there, and there's a search box. I've been sitting on it for a while, but let's say I just search for safety pins, something like that, and look at the amount that we have just on that word. So there's tons and tons of answers on our blogs, and there's even more. So I encourage everyone, if you didn't have your questions answered right now, there's a good chance that you can find a lot of information within our website.
That's great. No, thank you, Charles, for bringing that up. I wanted to thank everybody today for attending. Look, we had a great participation. We did not get through probably a third of the questions that were asked. There were just a tons of them coming in. Great interest in asking questions of an engineer. So I appreciate everyone. And for those questions that were not answered, I promise you we'll get back to you. And I think Charles made the right statement in saying, look, we have tons of great information on our website, blogs that cover just about everything around rack safety. So I'd encourage anybody who did not have their question answered to go take a look there, but we'll make sure we follow up with you. So So if you find yourself in a jam, you're concerned about OSHA, or you're concerned about your capacities, or any question about rack safety, we love to be able to help. We hope that we've convinced you that we know what we're talking about. We look at providing solutions to our various customers between the rack engineering expertise that we have, between the rack safety products that we have on the repair side and the protection, and of course the training that we're awfully good at giving. Sometimes we can go on site and provide the training, or even do it remotely, which seems to be the more popular of the options, to the platform that we have, that is a novelty in the industry, and something that I think that is leading the pack in terms of being able to efficiently show what's going on in your warehouse. So if we can go on to the next slide. So to re-emphasize the various services that we offer. So clearly we offer inspections, third-party audits. For anybody that's concerned about the condition of their racking, feel free to reach out and ask us to quote or answer some questions on that. Load capacity calculations, again, infrequently, rarely, if ever, will an OEM provide load capacities on somebody else's racking, right? So if you have Fraser racking on one area and you have Unarco racking elsewhere, one will not assess the other. I mean, it's just they stay in their lane. So looking for somebody that could provide capacities on various racking is important, and we have the capabilities to do that. I spoke about the training element already, so I think we're covered in that regard. And in terms of solutions, look, there are other ways to go about addressing an issue or damage to your uprights. Yes, replacing the component like for like is a great option. But if you're looking for something different, where you're concerned about the value proposition, whether it's going to withstand the test of time, whether it's going to be less impactful to your operations, please consider an engineered repair solution like you're seeing on the screen, whether it's for the upright itself, like the columns, or maybe just the brace. If you have a damaged brace, the weld popped on it because of an impact, you don't have to replace the entire upright. There are solutions on the market like ours. I think we're the only ones with this solution that'll restore the capacity of your upright by replacing that broken component. And of course, on the protection side, if you think about the flywheel, we talked about the inspection, the insight, the maintenance. There's that preventative maintenance piece as well. Invest some dollars into protecting your assets, whether it's the upright column that you're protecting, whether it's the building column that you're protecting, or other areas where you have sensitive equipment that you want to protect from damage. So look into those potential options as well, because they're going to save you dollars down the line. So thank you once again for all that attended. A really great turnout. I appreciate all the questions that were asked. Very insightful stuff. Charles, you're amazing as always. I would encourage anybody that wants to reach out to go to our website. You can fill in a form or just give us a buzz, and we'll happily give you a call or write you back with an opportunity to talk more about what we can do to help.